Hello dear student, today I am going to make you understand icse 2025 a question based on liver. So we have a question right now for 3 marks, and over here figures are given. So these are the figure I am making you understand about the figures for it. First, it is a figure of based of effort, load and fulcrum, and the next figure will be same. This is effort, this is fulcrum, this is load. And if you move to jump to this figure number 3rd, we have effort, load and fulcrum is situated. So before knowing this, these are the 3 levers x, y and z of equal length. So let us suppose the length of this lever over here would be, let us suppose it would be like 40 centimeter. So this lever would have the same length of 40 centimeter, and this lever also have a length which is 40 centimeter. So in the statement it is clear now. These 4 lever, 3 levers x and y and z have equal length. So I have assumed this one is said to be 40 centimeter, this is also 40 and this is also 40. So we have assumed that. Now we have to classify which class of lever do this belongs to. So this lever is named as x, this lever is named as y, this lever is named as z. So we have to say which class of lever these belongs to. And dear student, as I have already marked and made you understand in my previous topic about lever, is that if the fulcrum is situated at the center and this is like a effort and load, this will be a first class of lever. So this is I am going to make you understand a type of lever. So we have a concept regarding to it, how to remember the first, second and third class of lever. So we have to learn this concept known as FLE, F-L-E. And if you know this word, F is stand for fulcrum, which is a pivoted point, and load which is being applied on the machine, and effort, I am being applying the effort on the machine and load is there. We supposed to put a load over here. That figures are given over here. Effort, let us suppose we are applying the effort on the machine and the load is being suspended over here. This is effort, this is fulcrum, this is fulcrum, this is load. And what you are observing, we are finding between effort and between effort and load, we are finding the fulcrum between effort and load, and this will be termed as first class lever. Then if you are moving with this second class lever, the effort and fulcrum, we will place a load in between it, and the second class lever and the third class lever will place effort is between fulcrum and the load. Let us move from this summary. We get to know that whenever the fulcrum is between effort and load, this could be termed as first class of lever. And dear student, if you want to see this figure, you'll see the fulcrum is placed between effort and load for this case, effort and load for this case, and effort and load for this case. So our first answer will be which class of lever do this belongs to. So our first answer will be first class lever. So our answer will be first class lever. Now jump to the next important key point to understand this question. Among x, y and z, which will have maximum mechanical advantage? So let us discuss the formula of mechanical advantage of a lever, that is known as effort arm by load arm, effort arm by load arm. So how to remember which one is effort arm and which one is load arm? This is a simple diagram of a lever. So if I placed a fulcrum over here, this is fulcrum, this is load, let us suppose, and this is the effort I am applying. To mark the distance of an effort arm, it has to be from fulcrum to the end point where the effort is being applied. So this is known as displacement of effort, can be termed as dE. This is the symbolic representation of displacement of effort. And from here, this would be load to fulcrum. Always we have to measure from fulcrum to the point where the load is being suspended. So this is the symbolic representation of displacement of load, that is a load arm. So we got this formula to find the mechanical advantage. Now then, as we know, effort arm would be greater than load arm, then this equation can be termed as like this: load arm being multiplied with 1. Whenever the quantity is being multiplied with 1, when it moves from LHS to RHS, it will be divided. So once we have divided this, so we got an equation: inequalities is greater than 1. So this equation we got it. So further, in place of effort arm by load arm, we can substitute the value of mechanical advantage is greater than 1. Then mechanical advantage value will be positive, means greater than 1 it is coming. Is it clear? So from here, if you are observing this figure X, Y and Z, you are observing and you are noticing the effort arm is greater over here. Look, from here to here the distance of effort is greater, look, as compared to the displacement of load. So which could be termed as load arm, and this is termed as effort arm. This is termed as effort arm, this is termed as load arm. So if you are comparing with this equation, you will get to know that effort arm in X lever, the effort arm is greater. So once the effort arm is greater than load arm, and we have already obtained the relation. From there, the mechanical advantage will be greater than 1. So from this, lever X1 would be having maximum mechanical advantage. So our answer of this is X is having maximum MA. Now it's clear. Thank you everyone.